Okay, I would like to learn something new, right? I'm trying to be a good example for my students who I'm always asking to learn something new yourselves. I'm learning something new. I'm using something called Screencastify, and I'm going to try using this for my videos for a little bit. And hopefully it works a little smoother. Again, I've been having trouble the last few days making videos, so hopefully this goes smoother, and it will also allow me to pause and edit more often. I think there might be some advantages to learn something new. So this is your warm up for Thursday. Okay, January 7th. You know the drill. Copy it, go try it, then come back. You definitely might want to come back and check your diamonds. But on these, we haven't done in and outs in a while. Okay, and don't freak out. It has the in, it has the out. Remember, it's a function. So whatever I did to the 0 to get to 3, I'm going to do the same thing to the 1. That'll get me the 5. I'm going to do the same thing to the 2. That'll get me the 7. Okay. So check it out, see if you can figure it out. And if you can't, come back and see the next few, because each out that I add to this is another clue. And when we do this in class, oftentimes I'll get kids to give me what happens when 3 goes in, and they tell me, and then I'll look up and I'll see a couple light bulbs go off above kids' heads. Right. And then some kids are still looking at it. And then I'll say, what happens when 5 goes in? And someone will give me the answer, and then a couple more light bulbs go off. And it's so cool for a teacher to see the look on kids' face when they discover, oh, I got it now, right? I figured it out. It's kind of cool. So don't deny yourself that fun, that joy of figuring it out, um, uh, by pausing every once in a while. And after you get another one here, right? And another one. Pause it and think about it. See if you could figure out what you think the next one's going to be, and then guess and go check it. Okay. So take your time on those. Okay. They're kind of fun to do. And don't freak out that it says X up here for the in and F of X equals Y for the Y or for the out, right? Because that's something that we're going to add later, and they'll say, oh, it'll be a while later. I'm going to write it for a while. But then later you're going to say, I know why he was doing that. Right. Right. It's called planting seeds in your brain that we're going to water, and they will grow. And sooner or later, you will have some ripe fruit to enjoy. Okay. All right. You know the drill. Go pause, come back, and check it out. Okay. Hopefully you didn't have a heart attack when you saw this. Remember, you don't have a heart attack. You're too young to die. 42, and it wasn't a 13. It's 23. What are you talking about, Mr. Dan? You always put 42 and 13 because 6 and 7. What else could you use as factors to equal 42? And again, if you totally get stuck on factors, you want to find them all. Remember, factors are what we call finite, right? El fin means the end, finite, finish, final, finale. All those words start with el fin. It's a Latin word for the end. Finite. There's an ending for the number, right? There's no ending. If I say, give me all the multiples of 5, you start with 5, then you say 10, you say 15, you got 20, 25. Sooner or later, you're going to figure out that Mr. Daniel's being mean if he asks me to get all the multiples of 5, because there's infinite, right? You never finish that. But factors are finite. I want to get all the factors of something. There's an ending. I don't care how big the number is. This one doesn't have that many. You start with 1. 1 times 42. It's even. 2 goes into it. 2 times what? Half of 42. Right? Does 3 go into it? How do I know? Well, 4 plus 2 equals 6. 3 goes into 6. 3 is going to go into 42 or 420 or 240 or 24, right? How many times? Just so happens it's 3 times 14. How about 4? Well, it was 2 times an odd number, so 4 is not going to fit. But I can check. 4 times 10 is 40, right? Okay, I'm going to have leftover. Well, 5, no, it doesn't end in a 5 or a 0, and you know the famous 6 times 7. Now, you see how these numbers get bigger, why these numbers get smaller? All I have to do is check what's in between these two. Is there anything in between 6 and 7? No, so I have that's all the factors. Now, 1 plus 42, what am I looking for? I'm looking for 23. No, that's 43. 2 plus 21, that is 23. Boom, boom, boom. Ding, 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 ding. All right. I won't spend all of the time with all those, right? On this one, 1/2 plus 1/2, equals 1 whole, 2 halves, right? And remember, multiplying fractions is, hopefully you said easy, because you go straight across top, 1 times 1, straight across bottom, 2 times 2. And the other thing you want to know about multiplying fractions, 1/2 of 1/2. What's 1/2 of 1/2? Well, there's my 1/2. Let's take half of it. What's that? Well, that's 1/4. Of in math means 1. It means multiply. Okay, that's going to be valuable this chapter, because we're going to be doing a lot of what's called translating. I call it translating. Translate English to mathish, right? Because when you're writing equations and expressions. All right, 8/1000ths, 2400ths. What's that? 2/10 and 400ths. Remember, line up those decimals when you add. Fill in zeros if you want. Easy. When you multiply, pretend like there's no decimal. 2 times 4 is 8. And then I had to move the decimal over 1 spot to pretend that was a 2. I had to move it over 2 spots to pretend that was a 4. So total, I moved decimals over 3 spots in my problem. I got to go back 3 spots in my answer. What do I do with that empty spot there? Fill in the egg carton. That's how you get the 8/1000ths. 1 and 2/10 and 2 and 6/10 is 2 and 6/10. 2 and 6/10 is the answer. 2 times 6 is 12. I only had to move that over 1 spot, so I go back 1 spot. That's how I get that. 2 plus 6/10 is 2 and 6/10. Okay. All right. Hint for you here. Okay. When 3 goes in, do you know what's going to come out? Give me a guess. Okay. I've already forgotten what we're doing here, because this isn't working. Oh, no. I apologize to you. I made this hard, okay? What's going to happen when this goes, the next thing that's going to happen is I'm going to say this equals 9, okay? And what's going to happen when the 5 goes in? 13. If you said 11, that's what would have happened if 4 went in. Okay. And really, I shouldn't have made this hard. Okay. What happens when 10 goes in? Well, if you knew how to get what happened when 5 went in before, without having to do 4, you know the function. If you have to do 6, 7, 8, 9 to get 10, okay, you might know this pattern, right? It's going up by 2 each time, right? But if I do that, then I have to do, okay, 6, then 15, 7, then 17, 8, then 19, 9, then 21, and 10 is 23. Okay? That's knowing the pattern. But the pattern makes you do all the numbers in between. The function is kind of cool to know because it's a shortcut. Okay? What happens when 20 goes in? 43 comes out. How about 25? 53. How about 100? Do you know? 203. Whoops, not 2003. 203. What happens when X goes in? Well, what you're doing is you're taking whatever went in and you're timesing it by 2, and then you're adding 3. Okay, so that the fact that these were going up by 2, that was a good clue that I'm going to multiply it by 2. But something else would happen, right? 0 times 2 is 0, plus 3 is 3. 1 times 2 is 2, plus 3 is 5. 2 times 2 is 4, plus 3 is 7. 3 times 2 is 6, plus 3 is 9. Okay, so this was a little bit more difficult. Now, how will you write x times 2 plus 3 when you're in 8th grade? You'll say 2x plus 3. Means the same thing. Okay? All right. Sorry I made that so hard. We haven't done those in a while. I should have started you back with something a little bit easier. How about this one? Okay, 0 goes in, negative 2 comes out. 1 goes in, what comes out? Okay, 2 goes in, 4 comes out. All right, when 3 goes in, what's going to come out is 7. When 10 goes in, what's going to come out? You know, 28. When 15 goes in, what comes out? 43. When 20 goes in, what comes out? 58. And this is 298. What's going on here is I'm multiplying whatever went in by 3, and then I'm subtracting 2. Again, when you write that in 8th grade, you're going to say 3x minus 2. And I apologize again. I probably made that a little bit more difficult. Since we hadn't done these in a while, I should have eased you back into it. I just threw you in the deep end with the cold water. All right. Hey, you guys are tough. All right. On this one, make sure that you did not get 20 on this. Okay. The most popular wrong answer is 20. If someone got 20, what did they do wrong? They subtracted first. Remember, order of operations. We got to multiply and divide before we do any adding and subtracting. So I'm doing that 6 times 2 first, and then I subtract. 4 is the correct answer. Same idea here. The answer to this is not 160. If you got 160, you did 18 plus 2, and then you multiplied 20 times 8. You have to multiply first, okay? They happen first. So what you have here is 18 plus 16. Correct answer is 34. All right. Now, what's that backslash mean? Divide. I have to divide before I add. 3 goes into 24 8 times. So this ends up being 32, okay? All right, how'd you do? All right, you're going to finish this and check. 5 times what equals 100? 5 times 100 is 100, 500. 5 times 40 is 5 times 4 with that extra 0. Okay? Now, 40 times what is 800? Well, 4 times 2 is 8. There's one of the zeros. I need another one. So this is a 20. And then 20 times 1 is 2000, right? Or 2000. Okay. Now, 5 times what equals 30? Hopefully you got 6. And then you did 6 times 20. It's 120. Now, let's go add all these. Someone remind me to review the distributive property with these things. Okay. 5, 8, and 8 is 16. Carry the 1. 3,650. And let's double check. It says to check. What numbers am I multiplying? 146 and 25. Standard algorithm. 30, carry the 3. 20 plus 3 is 23. Carry the 2. And 5 plus 2 is 7. Put a placeholder because that's really a 20, not a 2. Cross these out so you don't get confused. 2 times 6 is 12. Carry the 1. 2 times 4 is 8. Plus 1 is 9. And 2 times 1 is 2. 3,650. Woohoo, did it right. All right. This is the part that if you persevered and you're still here, you have to know that this is the part that's going to help you on the homework. Check these out. Check these out right here. These problems here, written in a different way right there. Okay, so if you do this warm up like you should, that integrity will pay you off because then you're going to have the answers to the last 4 problems on the homework. Okay, all right. So how do I change a percent to a decimal? All you do is move it 2 spots that way. That is 0.13. Another way of saying that number is 13 hundredths. 13 hundredths as a fraction. Boom, I'm done. 1/5 divide the bottom into the top. You end up with 0.2. To change this to a percent, move it 2 spots to the right. Boom, boom, fill the egg carton. 20%. 2 spots to the right. Ooh, 130%. Remember, if your decimal is bigger than 1, your percent is bigger than 100%. Okay? And this is going to be 1 and 3/10. Okay, 32%, move it 2 spots that way, 0.32. And what is that? That's 32 hundredths. I would like for you to simplify that because 4 goes into the top and the bottom. 4 goes into the top 8 times. 4 goes into 125 times. Hopefully you got that, okay? All right. Good job persevering. Hopefully this video and sound come out clear as a bell and clear so you can see it well, because it's a new way of doing it, okay? Have a good one, everybody.